Okay, so here's section 5.7. And 5.7 is a lot about finding inverse functions, as you see right there. So remember how we find an inverse function? Step one is we invert x and y. So this is y. F of x is always y. So we swap roles with x and y. So it becomes x equals 4 plus, let me move this over a little bit. X equals 4 plus the square root of 3y minus 4. So we switch x and y, invert x and y. Step one. And then step two. Solve for y. So now here's the wall. Y is saying I want to be alone. Get rid of all this stuff. So let's start by subtracting 4 from both sides. Gonzo. And so we get x minus 4 is the square root of 3y minus 4. Now how do we're trying to get to that y there, trying to get that y alone, scribble in there. We're trying to get down to that y. The y is saying get rid of this square root, get rid of this 3 and get rid of this minus 4 so that I can be alone, right? Trying to get y alone. So how do we get rid of that square root? What's the opposite of a root? It's second power. You go parentheses second power, parentheses second power, both sides. And a root and a 2 power are opposites of each other, and they cancel each other out. So we get 3y minus 4. And the other side, we just have x minus 4 squared. And we'll just leave it that way. We don't need to square that out. Let's just leave it. We're still working to get y alone. Now we're getting close. So now we just add the 4 to both sides. And so we have x minus 4 squared plus 4. Last step to get y alone, divide by the 3. Divide by the 3. And there is the answer. That's the inverse function. That's the inverse function. What do? We inverted x and y. We switched x and y, trade positions, and then we just solved for y. Okay. Let's try number 2 down here. It's kind of similar. Again, step 1, invert x and y, trying to find the inverse function again. So this is y right here. So y switches positions with x. Becomes x equals, let me move that over again a little bit there. Becomes x equals 3 plus the cube root of y. Trying to, so we switch x and y, step 1. Step 2, solve for y. It's just 2 steps to find an inverse function. Switch x and y, invert x and y, and then solve for y. Okay, so we got to subtract. So the y over here is saying, I want to be alone. I want to be alone. Get rid of this, all this stuff that's next to me and on my side of the wall so that I can be alone. So what do we get? We get x minus 3. These cancel. Is the cube root of y. Good to there. Now, how do we get rid of that cube root that's on y? What's the opposite of roots? Powers. Powers and roots are opposites of each other. Just like up here, we had a root, and so the opposite of that was a 2 power. Now we have a third root, so the opposite of that will be a third power. So here, I'll bring it down one more line here. And then I'm just going to third power both sides like that. The third power cancels the third root, gets you y alone. X minus 3 to the third power. There's the answer. That's the inverse function. So again, we invert x and y, switch x and y, solve for y. And roots and powers are the opposites to each other. That's one of the main lessons they're showing us in this section. Roots and powers are opposites of each other. Now number 3, use algebra to find the inverse of the function. So here we go again. In fact, I think it'd be better if I had some room to work. So let's go back here. So for number 3, we have y equals minus 3x to the 9th minus 5. And they want us to find the inverse. So you know step number 1, invert x and y. So this y and x will trade spots. So the x will go out there, the y over there. Step 2, solve for y. So y is over here saying I want to be alone. Get rid of all this stuff. So our first step is to add the 5 to both sides. Like that. Next step is to get rid of that negative 3. Now that negative 3 is multiplied by y to the 9th, so I've got to divide it. Divide by the negative 3. All right, and it cancels it out here, and that gives us y to the 9th is x plus 5 over negative 3. Now, how do we get rid of that 9th power that's on that y? So what's the opposite of a power? A root, right? That's kind of the moral of the story in this section, that roots and powers are opposite. So the opposite of a 9th power is a 9th root. Whatever you do to one side, you have no choice but to do the same thing to the other. These cancel. That gets us y alone. It's the 9th root. That 9's in the hook. 9th root of x plus 5 over minus 3. Or, I want to show you another way, because on the multiple choice exam we take, they could write that another way. I don't know if you know. Do you know that it's the same thing if you write x plus 5 over negative 3 to the 1/9 power? 1/9 power is the same, I'll go same, as a 9th root. A 9 in the hook or a 1/9 power. Those are two ways to say the same thing. They could put the answer this way or that way. Both are good, and the homework system knows those are the same. It'll take either answer, and on the multiple choice exam, you know, they might have it one way or the other. Make sure you know both ways so you can not be confused on that. A 9 in the hook right here is the same as a 1/9 root, 1/9 power. So 1/9 power is the same as a 9th root. All right, let's try number 4. Number 4 gives us f of x equals 1 over x plus 6, and they want us to find the inverse. Find the inverse. All right, so you know step number 1, to invert x and y. So this is y out here, right? Functions are y. So switch x and y. So it becomes x on the outside, y on the other side. Okay. Number 2. Solve for y. So here we have the wall of separation. The y is saying, I want to be alone. So what do we always do when we have a fraction? Let me just put it back the way it was. What do we do when we have a fraction? How do we handle that? We always put this over 1 and go diagonal, diagonal, don't we? We cross multiply, so it becomes x. What am I doing? X times y plus 6 equals 1 times 1. Right? I just went diagonal. X times y plus 6 equals 1 times 1. And then we distribute. So that's x, y plus 6x. 1 times 1 is just 1. So here we go. Now, what are we doing now? Solving for y. Y is right here, and he's saying, I want to be alone. Get rid of all this stuff so I can be alone. So our first step is to subtract 6x from both sides. This is gone. So this just drops down. xy is 1 minus 6x. And now what do we do to finish getting y alone? Divide by the x. Boom. There we go. Now, can we cancel those x's? No, we cannot cancel those because of the Costco glue thing, right? This minus sign right here glues together the top, which means if you want to cancel anything in the top, you cancel it all or you cancel nothing. You can't just cancel part of it. It's a package deal, all or nothing, pluses and minuses. Glue things together, make them a package deal, all or nothing. So we're just done right there. There's nothing more you can do. Well, I will say this, just that's a fine answer right there. Or you can separate these two. Let me mention that. You can always, common denominator. You can always say, look, I'm just gonna put that x, under, it's under both of them, so you could separately put it under both. That's always okay. That's just common denominator. And then if you do that, you could cancel those x's because there's no glue between the 6 and the x there. So in other words, 1 over x minus 6, that's also a good answer. You don't have to. That's not any more simple or anything, but for purposes of the multiple choice exams we take, I want you to know those are both good. They're both right. Neither one is any better than the other. They're both viable options. Okay, let's go on with number 5 here. So number 5 is f of x equals minus x minus 4 over minus 3x minus 2. Like that. And again, they want us to find the inverse function. So you know the steps. Step number 1, invert x and y. So this is y out here. The y will trade with the x in both places. So it'll become x over here, and then minus y minus 4 over minus 3y minus 2. Like that. Okay, step 2, solve for y. All right, what do we do when we have fractions? You know this quite well, right? Put this over 1, diagonal, don't we? So it's going to become x times minus 3y minus 2 is 1 times minus y minus 4. Like that. Okay. And then we distribute. Let's do it. Boom, boom. So we get minus 3xy minus 2x. Distribute. Minus y minus 4. And we are, that line's not very straight, is it? There we go. And now we're trying to solve for y, but notice this term and that term both have a y. Okay, so 2 y terms. So what do you do when you have 2 y terms? Number 1, get the y's on the same side. So let's get the y's on the same side. So I'm going to jump this guy over here and then this guy over there. Remember, when things jump to the other side of the equal sign, they switch their signs. So this will be, this minus 3xy stays put, but the minus y here jumps over, becomes a plus y. And then this minus 2x jumps over, becomes a plus 2x, and the minus 4 didn't go anywhere. He just stays where he's at. Good so far. So notice I've got both the y terms on the same side. So you get the y terms on the same side. It doesn't matter if it's on the left side or the right side. It doesn't matter at all. I got them on the left side. Next step, factor out y with a big old parenthesis. So you put the y on the outside, and then you say, okay, y times what will go back to minus 3xy. Minus 3x. And y times what will go back to plus y. Y times what is y? Plus 1, huh? Y times 1 is y. Does that make sense? If I was to distribute that, it would go back, wouldn't it? The other side stays the same. Okay. So now, what are we going to do to finish solving for y here? Divide. So factor out y and divide. So divide by the minus 3x plus 1. Boom, there it is. Y equals 2x minus 4 over minus 3x plus 1. And that's the inverse function. We found it. All right, good. Let's go on with number 6. So, number 6. One more of these inverse function ones. They give us f of x equals x plus 2 over x plus 8. And they ask us to find f inverse of negative 6. They want us to figure out. All right, so how are we going to do that? Well, there's two phases to this problem. Step 1, find the inverse, f inverse of x. And then way down here, step 2, plug negative 6 into, I don't know why I put that I out there, funny, into the inverse function. So it's 2 steps. It's just like the last few problems, except at the end we have to plug, once we found the inverse, we have to plug negative 1 in there. All right, so the first part of finding the inverse, as you know, is to invert x and y. So this is the y. It trades with both of those x's, doesn't it? So we get x there, and y plus 2 over y plus 8. X and y trade spots. Step 2, or next step, solve for y. So you know what to do, right? When you have fractions, put this over 1, diagonal, diagonal. So we get x times y plus 8, 1 times y plus 2. And then we'll distribute xy plus 8x, distribute y plus 2. Okay, so here again we have y. What do you do when you have y and 2? Move this over. Y in 2 places. Remember, step 1. Get the y's on the same side. So I got this y term and this y term. I'm going to get those guys on the same side. So jump this over here, jump this over there. And so what do we got? We've got x, y minus y. The 8x jumps over minus 8x plus 2. So do you see, again, everything that switches sides also switches signs, right? So the xy stayed put. He didn't go anywhere. And the plus 2 stayed put. He didn't go anywhere. But the 8x plus 8x jumped over, became a minus 8x. And this plus y jumped over, became a minus y, because those guys traded sides. Okay, so see how we have the 2 y terms now on the same side? Step 2, factor out y with the parenthesis, and then divide. So factor out the y. Let's do it. Y times x will go back to xy, and y times minus 1 will go back to minus y. So I factored out the y. And then last step, to get y alone, divide by the x minus 1. Boom. So there is the inverse function. This is the inverse function. Now we bring it down here. So the inverse function is minus 8x plus 2 over x minus 1. That's the inverse function. That was all that work to find the inverse function. Now we've got it. So now what do? Last step on this problem. Normally we stop here. You got the inverse function, game over, done. But now they want me to plug negative 6 into that inverse function, right? That's what they said from the beginning. What's the f inverse of negative 6? So now we just plug negative 6 in there. So that's f inverse of negative 6 is, now plug in the negative 6. So we get negative 8 times negative 6 minus 2 over negative 6 minus 1. Multiply those together, that's what? Positive 48 minus 2 over minus 7. That's 46 over minus 7. Divide that on your calculator, you get they want a decimal on this one, minus 7.142857. That's enough decimals. I don't know how many they want, but that's plenty right there. Wait a minute, I messed up. This should be plus 2 here, shouldn't it? Plus 2. This should be 50. Okay, and then that gives us that answer, minus 7.142857. I forgot about the plus sign. I changed it for some reason. All right, and there we go. Let's go back to number 7 now. There it is, question number 7. All right, find the domain of each of the following functions. So how do we find domain? So we have this function. Now remember domain. We look, remember denominators? Remember what you can never have in a denominator? You can't let the denominator be 0, because if the bottom of a fraction is 0, that means the whole thing goes to infinity. That's where we have a vertical asymptote. And, you can't touch, a function can't touch a vertical asymptote, right? Anytime you have a graph, if you have a vertical asymptote, the function never touches it. So that's not in the domain. You can't go there. So I'm going to say, okay, whenever we have a denominator for domain, remember what domain is? Let me write domain again. Domain is allowable x values. It's what x values are okay or allowed. And any place where there's a vertical asymptote, you can't touch it. It never quite touches the dotted line. So at that x value, you can't touch it. It's not in the domain. It's not an allowable x value. The graph doesn't quite touch it ever. So, and that comes when the denominator is 0, doesn't it? That's what makes the fraction go to infinity, makes a vertical asymptote. So denominator cannot equal 0. At least where it does equal 0, the x value will not quite go there. So what does that mean? That means minus 2x plus 1 cannot equal 0. Let's solve for x. So I'm going to grab that plus 1, where I'm just going to subtract 1 from both sides. Let's just do it that way. And then I get minus 2x is minus 1. And then how do we solve that for x? Not equal to, divide by negative 2. And we get x not equal to positive 1/2. So x can be anything, but except it cannot be positive 1/2. Well, how do you say that? Well, here's the number line. We're saying right here at positive 1/2 there's a hole. Anything else is okay, but it cannot equal positive 1/2. That means all these numbers are okay. From negative infinity, that's left forever is negative infinity up to 1/2. And all these numbers are okay from 1/2 up to positive or regular infinity. So that's how they got this answer, right? Everything from negative infinity up to a half. Parenthesis there. Why parenthesis? Remember, because you can't touch the half. Remember, if we did a bracket, if you have a straight edge bracket, that means you're straight on the half. And we can't touch the half. That's the whole point. You can't equal the positive a half. You can't equal a half. X can't go there because that's where a vertical asymptote is. That's where the denominator is 0. You don't touch a vertical asymptote. You don't touch the half. United with, again, parenthesis, this section, which is a half to regular infinity. So this section from negative infinity up to a half, and then from a half to infinity. That's a way of saying everything but a half, right? There's just a hole right there at a half. We never touch the half. Everything else, that's what that answer is. Let's come down here, and let's do, in fact, let me just go to a fresh screen to do the second part right here for number 7. So number 7. The second part is f of x equals the square root of minus 2x plus 1. Want to find the domain. Again, what is domain? Allowable or possible x values. Well, with a square root, what can you not put in a square root? You can't take the square root of a negative number, right? Like square root of negative 9 is imaginary. You have to bring in I, right? Because there's no number times itself that's negative 9, is there? So basically, if you have a square root and you have the inside of a square root, you say, hey, inside, you have to be, you're not negative. How do you say not negative? Greater than or equal to 0, right? Because not negative means positive or 0. If something is not negative, it's positive, it's 0 or bigger. 0 or positive, right? That's not negative, so that's greater than or equal to 0. So that's what we do when we have a square root for domain. We say, hey, inside, you have to be greater than or equal to 0, because you can't be negative. That's not allowed. So then solve for x, subtract 1 from both sides. Minus 2x greater than or equal to negative 1. Last step to finish solving for x. Divide by negative 2. But remember what happens when you divide by negative. Flip the symbol. So we got to move the symbol the other way. So it becomes x less, turn the symbol the other way. Turn it the other way. 2 negatives, positive half. X is less than or equal to positive half. How's that go on a number line? Well, here's a half, solid dot, and a half less than, so it's this way. So basically it's everything from negative infinity up to a half. So how do you say that? Negative, parenthesis on the negative infinity, because you're never straight on infinity or negative infinity, up to the half, bracket on the half, because we're equal to the half. We're solid dot straight on the half. There's our interval. And then the last one, number 7, the last part here, they're giving us f of x is log base 6 of minus 2x plus 1. Okay, and they're asking us for the domain, which again, domain is allowable x values. So now I haven't told, so far we have 3 things, right? We have, if you have whatever, blah, 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 over a denominator, you say denominator not equal to 0, and then you solve. Because the bottom of a fraction cannot be 0. That's infinity. That's a vertical asymptote line. X can't go there. You don't touch a vertical asymptote line. And then we have a square root with something inside. In that case, we say, well, the inside of a square root can never be negative. It must be greater than or equal to 0, meaning not negative. 0 or positive, right? And then step 3, this is the one I haven't told you about before. Been keeping it a secret. No, I'm just kidding. Basically, try log on your try for a second. Take your calculator, take log of, I don't know, whatever, -2. It'll give you an error, and even try like log of 0. That's supposed to be a 0 there. You'll also get an error. So basically, we can never have 0 or negative inside of a log. We can never have 0 or negative inside of a log. So this gives our third, domain is, what's allowed and, what's not allowed. That's what it's all about. So what's not allowed with a log? So if you have a log and you have something inside, doesn't matter what the base is, called b for the base, whatever, doesn't matter at all. Take that inside and say, hey, inside, you have to be what? Never 0 or negative. Not 0, not negative. Well, what does not 0, not negative mean? Only positive, huh? Greater than 0. It has to be greater than 0. Only positive. I'll write it down here. Only positive. That's what not 0. If I say, hey, I'm thinking of a number, it's not 0, and it's not 0 and it's not negative. Well, then it's positive, meaning it's greater than 0. So it's almost like what we do here, but this is greater than, this is 0 or positive, this is only positive, right? Inside of a square root, 0 is okay, but inside of a log, you can try this one on your calculator, 0 is not okay. And we can never put a negative inside of a root, and we also cannot put a negative in a log. So a log is just like a root, except it's a little more restrictive. You can't have 0, and you can't have a negative, so it's only positive, only greater than 0. Inside of a root is just not negative, so 0 or positive is okay, so we say greater than or equal to 0. Those are similar. Okay, so we just grab this inside. We say, hey, inside, you have to be greater than 0. Only positive. Only positive. Not 0, not negative. Right? No negatives, no zeros inside of a log. So then we just solve for x. So subtract 1 from both sides. Boom. Minus 2x greater than -1. Divide by -2. Remember what happens when you divide by a negative. What do? Right there. Flip the symbol. When you divide by a negative, flip symbol. So flip that the other way. These cancel. We have x less than, the two negatives makes positive 1/2. So let's put that on the number line. So open circle at 1/2, because it's not equal. It's not solid there. It's just less than. So it's just this way. From negative infinity up to 1/2, and we'd put a parenthesis at 1/2 because we're not equal to the 1/2. We're just less than the 1/2. There's an open hole there. We don't quite touch the 1/2. We're only less than the 1/2, not less than or equal to. That's our answer for that one. All right, let's go to number 8. So number 8, they want us to match the following functions with their graphs. Okay. So this is so remember the square root graph, which normally starts at the origin. That's y equals the square root of x. It just starts at the origin. But notice this one has been moved down 1. What's going to move a graph down 1? Well, when you put a -1 outside the square root, huh? So there it is. That was easy. How about part B? They moved it down 2. Well, this is also very easy. There it is. These are a piece of cake. Let's go to C. This one's been moved up 1, so this is easy. Up 2. This is easy. Wow, that was a very easy problem. I thought they were going to be a little more tricky than that. All right, let's see number 9. Now this one's more tricky. Now they're moving it right and left. This one's been moved right 3 over to +3. What makes that happen? It's actually -3 next to x. Remember, whenever a number is next to x, it is opposite. We've seen that several times, haven't we, in different situations. Whenever a number's next to x, it's opposite. You might think, well, that didn't happen over here. Well, notice like this 1 or this 2, they're not next to x, meaning they're not in the root. They're not in x's world right there next to x. No, this 2 is outside of the root. This 1 is outside of the root. So that's what makes it go up or down, because it's not in x's world. It's not an x effect. It's a y effect. It's an up-down. That's up 1. It's not a right-left thing. But here on number 9, this guy got in the root with x. He's in x's world. So whenever you're in x's world, you're in x's world, and you're right next to x, you're always opposite. So plus 3 becomes minus 3. This one minus 3 becomes plus 3. This one minus 1 becomes plus 1, and plus 1 becomes minus 1. Notice all those are in the root right next to x. So that's why that happens. And number 10, this is our last one. The time it takes for a pendulum to swing back and forth is this function here, where s of x is the time in seconds, x is the length of the pendulum in feet. So it's like a pendulum. You know, if we have like, you know, something like this, and it's swinging back and forth, like a clock hand, you know, or something swinging, a swing set, swinging back and forth, that's a pendulum. That's what a pendulum means. Just something swinging back and forth. How many seconds will it take for a 7-foot pendulum to swing back and forth one time? Well, x is the length of the pendulum, so they're saying x is 7. So just take that function, plug in 7. So it's 2 pi times the square root of 7 over 32. So you got to put that into your calculator. You're going to have to use the pi button on your calculator. So type that into your calculator. You should get the answer they have down there, 2.9 seconds. So type that in, see if you can get 2.9 seconds. Now the next question is going to be more tricky. If it takes 6 seconds for a pendulum to swing back and forth one time, what's the length of the pendulum? So we're using the formula again. S of x is 2 pi. Whoops. There we go. Get that out of the way there. 2 pi times the square root of x over 32. And they're telling us that it takes 6 seconds. Well, s of x is the time in seconds. So they're saying this whole s of x is 6. And they want me to solve this equation for x. So here we have an equation. X is saying, I want to be alone. Get rid of all this stuff. Get rid of this 2 pi and this square root and this 32 so that I can be alone. Solve for x, right? X is the length of the pendulum, right? X is the length of the pendulum. Solve for x. Well, okay, let's do it. It's like peeling an onion. Let's start on the outside. Let's first get rid of the 2 pi. Divide by that 2 pi. Boom. And so we get 6 over 2 pi is the square root of x over 32. Now, how do we get rid of that root? What's the opposite of a root? You know what the opposite of a root is. It's a 2 power, right? So if I bring this down here, let me just rewrite it for clarity. We're going to go 2 power, and it cancels that root. Brings it up here. Oh, by the way, we should also go 2 goes into 6 3 times. I should have done that back here, huh? So this becomes 3 over pi to the second power is x over 32. Do you see what happened there? The 2 canceled the root. It's gone. So we did a 2 power on both sides. It stayed on the left side right here because there was no root to cancel it out. But on the right side, the root and the 2 power cancel each other out, so they're both gone. So now last step, how do we finish getting the x alone? We bring it down here. So x over 32, 3 over pi squared. How do you finish getting x alone? Multiply by 32 over 1. 32. Both sides cancels out. X is 32 times 3 over pi squared. Hit the buttons on your calculator. You'll get 29.2. They want you to round to one decimal place. And there we go.